Basic operations of a neural network. So with neural networks, you have input of data that is either images, text, numbers. It can be any of those types or sometimes a combination of all of them. And these get a weighted sum of the inputs, then goes through an activation function to produce an output answer for whatever the input was. It is then compared to a true label, which is using its loss function. Its loss function is a squared error in how wrong the answer it is originally giving is. So it's kind of like how people think something through in their head first and challenge that thought before speaking it out loud, which sometimes saves you from saying very unintelligent things out loud. And this is the way that the AI will stop hallucinations. So back propagation is then used to calculate the weight of the contributor to that error, which is like it seeing what the problem in the scenario was, and either elevating the weight of it because this was the correct answer for this situation, and then whatever gave a bad answer initially then gets its weight kind of knocked down a little bit. And this happens every single input that is being used. This can then also create generalizations with unseen data that can create accurate predictions, where it may not know a certain piece of information, like that the sky is blue. But I have 1,000 pictures of the sky, and I kind of know that 99% of the time it's blue, and every time I've been wrong, saying it was orange or red, blue has always been the right answer. So generally, the sky is blue, unless you live in Seattle. Now, the activation function. The activation function, it is the mathematical equation that is used in neural networks to determine the output of a neuron after receiving an input. Without the active functions, neural networks would just be a linear model. So, and that is with no matter how many layers that this may have, which means that with having the active function, it can understand curves, it can understand outliers, it can understand small pieces of data that may not fit in with the normal progression, but are still relevant in the data set, which kind of gives it that niche ability to grab at certain pieces of information that don't sit on the normal flowchart. Because with linear, it can only see straight lines. It can't see curves, and it can't see anything else. Now, it will also make most of its decision based on multiple inputs and not just the sum at the end. It will take multiple pieces. It's a multi-step equation versus just saying A plus B now, this equals C, which gives it a lot more range and level of depth to questions being asked to it. Some of the common active functions are sigmoid, ReLU, and ton. On to gradient descent. Gradient descent. It is an optimization in the neural networks trained to minimize the loss function in these models. And this is done in a very specific order. It is done by starting with the current weight, making the said prediction, calculating the error loss, computing the gradients, and then updating all of these weights, which it could be maybe 1 to 2 weights are getting adjusted, or especially in the early stages of development, that could be hundreds of thousands of weights being adjusted. The problem with that is that humans cannot understand or easily follow this ideology that the machine is using, and it's based only on, numbers, facts, and hard data. So it cannot have that human piece in this. But also, if you have bad data in these machines, you will throw off medians, averages, and you could put in these bad pieces of data that might supersede what could be corrected later on. and could just increase the time that it takes to train these neural network AI models overall.